Thursday. Again, covering 1-6 to 1-8b. And in 1-6, we started with rational equations. So we've done these before. These are ones that have variables in the denominator. And these are ones that we would start by finding out what x can't be from that denominator. So I would just set my denominator not equal to 0. And then I would get like x can't equal 0 and x can't equal -1. And then when I solve, because I'd multiply everything by the least common denominator, and this time we're canceling out those denominators, I would solve and I would get my values for x. I feel like these are easy and quick to check, so I wouldn't say like you have to wait till the end for these. You could literally, if I get a -1, I know I can't keep it, I cross it out. If you have two answers and only one doesn't work, you cross it out, you keep the other. If it's only one or both of them don't work, obviously that's when it's a no solution. Then you got into like 1-6, this was still A, which was the factoring and the substitution. So you could see stuff like x to the 4th and x to the 2nd, or x to the 6th and x to the 3rd. And then you had the weird ones that looked scary, but we just used substitution and help with, like the 2/3 and, oh, this should be 1/3. These were on your quiz, like that one, there was one like that on your quiz. So for the first one, you don't want to use substitution because you lose the plus or minus. For the first one, I would say, I want to put it in parentheses and I want to factor it like I normally do, except the first term is x squared instead of x. So then I'd be looking for the factors of -15 that sum to -2, which are -5 and +3. And then I split and solve these. I get x squared equals 5, and I square root both sides, putting the plus and minus in front of the root. And I get x equals plus and minus root 5. And then on the other side, x squared would equal -3. And when I go to square root these, plus and minus the square root of -3 gives me plus and minus I root 3. So these, like this section, the even root stuff, is really the only time you're going to see the i's. You won't use i's if there's like the inequalities. We don't use i's. It only would come into play on this stuff. And then the next one you would take like whatever's in here. So if this was like x plus 2, I would say x plus 2 to the 1/3 is my a. I would make it a squared minus 2a minus 15 equals 0. And then I factor it. Same factors, a minus 5 and a plus 3. Split and solve. And then we have to set them back equal to what we said a equaled. And I'd cube both sides. Cube both sides. And I get 2 answers. So don't let a question like that scare you, right? It looks scary from the beginning, but it's the same process every time. Figure out what A is. Plug in the A, factor it, solve it, and then make sure you set back equal to the A so that you can get all the way to that answer. So that was like one like that was on your quiz. And then you had like quadratic that was on your quiz. That will come back to. Questions on either of those? Okay, then came the radical equations, right? So this was like 1-6b, I think. And we started with there's just one square root. So if there's just one square root, we would square both sides of the equation and it would get rid of the square root. Then we had if there's 2 square roots. Well, if there's 2 square roots and it's just the square roots, we can square both sides of the equation again. But if there's a factor there with it, like that 2 plus the square root, then we square it, but we have to expand and FOIL this side or use the shortcut, which is square the first, square the last, and double the product in between. So if this said, let's just say it said this, and I wanted to square that, square the 2, double the product, so it'd be 2 square root x plus 3 times 2, or x minus 3, sorry, or plus 4 square root x minus 3. And then square the second one and you get the x minus 3. And then you had to move everything to one side. You had to square it again, right? Those were the worst of them. And you are going to see something like that. So you want to make sure you practice it. What happens if there's a square root on either side of the equal sign? And then what happens if when I square it, there's still a square root? That means I have to do it again. Those two both have to be checked. So anything with that square root has to be checked. But I would strongly wait and strongly recommend waiting until you get to the end. So if you get all the way through your test and you've got the extra time, plug those things back into the square roots. If not, don't worry about it. It's not worth it. A question like the third one there, one's being raised to the 2/5 and one to the 1/5. So if they're weird fractions, but the bottoms are the same, you can raise them both to the denominator. So it would cancel. The left side would still be squared, but the right side would no longer have an exponent. And then I would expand and FOIL the left-hand side, combine my like terms, do what you need to do. For the last one on here, if I were to raise it to the third and then square root it, I have to deal with 16 to the third. That's a big number, right? And you could see a lot of cube roots there. So I could have put 64 there, and that's a big cube root. I could put 125 there. That's a big cube root to then, or cube, right? So the easiest thing to do there is to do the reciprocal. Good. Just remember that when you're doing it, by raising it to the 3/2, you're technically square rooting that side. So you have to do the plus and minus. So I'd get whatever's in here equals plus and minus the square root of 16 cubed, which means one of them is going to be negative 4 to the third, and one of them is going to be positive 4 to the third. So you'd get negative 64 and positive 64. And then because it was an even root, this one also needs to be checked. But again, I would wait all the way to the end for that.
What do you mean even?
Say again?
What do you mean by even root?
Like when we square root it, it's an even root.
Oh.
Yep. All right, and 1/7, and really the only thing that because we're gonna blend it in with 1/8, like inequalities, was your absolute value. So if your absolute value equals a number, then we set whatever's in here equal to the negative of that number and the positive of that number. The complicated ones from absolute value, you don't have to worry about. Like the ones that said like absolute value of x squared plus 3 equals x minus 8, and we would set it equal to the positive and the negative version of the other side, so you had to check it. You don't have to worry about those, okay? Just absolute value. Not with like a squared where you get two answers and you have to plug it back in. Not on the absolute value. And then came the 1/8, all the inequalities. So the left side was 1/8a and the right side is 1/8b. We started with like quadratic inequalities. So this is where our number line comes into play. We solve this as though it's equal. So I'd get x plus 5 and x minus 5. Split and solve it, and I get negative 5 and positive 5. God bless you. And then I'd get negative 5, positive 5. If 0 is not a root, I always choose it. So 0 would be in between here. I plug it in. 0 minus 25 is greater than 0, and negative 25 is not greater than 0. So I cross out the middle, and I use the outer two sides. And because it's not an or equal to here, it gets parentheses. So I get negative infinity to negative 5 and 5 to positive infinity. For the inequalities, they are all going to say write your answer in interval notation. So they're all going to be written in interval notation, but you do not have to graph them. Obviously, you graph them to get to your answer, but you don't have to graph them for points, like test points. All right, then you got something like x squared minus x minus 4. This is not factorable. What do you have to do there? Quadratic. So like a is 1, b is negative 1, and c is negative 4. I actually didn't try this one yet to see if this works, but 1 plus and minus the square root of negative 1 squared minus 4 times a times, it will work, c over 2 times a. 1 plus 16 over 2. Okay. Now these are not whole numbers, right? I got to figure out approximately where they are in my number line. 1 minus square root 17 over 2 is definitely going to be less than 1 plus square root 17 over 2. But I don't know where the negative lies yet. Really, I just have to see if square root 17 is bigger than or equal to 1. And it's bigger than 1, which means that one's going to be a negative. This one's going to be a positive. So the 0 is in between. If you want to actually approximate it, like 17 is like just a little bit bigger than the square root of 16. So this could be like a 4.1. And then I could keep going. I could do 1 minus 4.1, which is negative 3.1 over 2. That's definitely a negative number. And then 1 plus 4.1, 5.1 over 2, which is definitely bigger than 1. Yeah.
So we'll have to worry about having problems on the test that kind.
You're definitely going to have a quadratic with the inequality. Yeah. Rodrigo.
What if have an imaginary number?
You won't. With inequalities, you won't, because you can't plot those on a number line. The only time you're going to see the imaginary number is like the beginning ones with the factoring. Yeah. Sure. Yeah. All right, so then I would plug in like the 0 because it's in between 0, 0, negative 4 is less than or equal to 0. So I would shade in between and they both get brackets. And when I write that answer, it's kept exact, not the approximation. Here's what you're not allowed to do. Give up because it's quadratic. You could at least get to, even if you don't know like how to approximate and find the 0, you can at least get to this point on your, and it might be easy. It might be that's like, oh, that's definitely a negative and a positive, and it's okay. You're not allowed to give up because it looks scary. You could skip it and go to the easy stuff and then go back to it, but you're not allowed to give up. All right, then we had our absolute value with the inequalities. Whether it was less than or equal to, this becomes an and statement. And if it was greater than or equal to, it became an or statement. So if it was less than 10, this was negative 10 is less than whatever's in the middle, which is less than 10. And if it was greater than 10, then it's negative 10 is greater than whatever was in the middle, or whatever's in the middle is greater than 10. When you like it'll be easier when you get to an example. Yeah. So like if it said absolute value of x plus 2 is less than 10, because this is when you guys were gone. I told them to read that out loud, like read that in your head, but like listen to it. Absolute value of x plus 2 is less than 10, and less than ends with the and sound, which makes this an and statement. So I do the negative 10 on the other side. I keep the sign going in the same direction, so small on the left and big on the right. And then I write what's in between the absolute value, and then I continue out the rest of its statement. And then I would subtract the 2, and I get negative 12 is less than x, which is less than 8. And then that's on my number line in between negative 12 and 8, parentheses on both sides, so the interval notation looks just like it. If it's an or, which is absolute value of x plus 2 is greater than, let's say it's greater than or equal to 10, great or, sounds like the or, that's a negative 10, sign going in the same direction, so big on the left, small on the right, whatever's in between the absolute value, or, and then write out your original statement without the absolute value. And then same thing, solve it, negative 2.
So you switch it?
Yep. And then this side, I put the x first. Like I just like rewrite it, the order, so my brain can read it left to right. The big part still faces the negative 14, so it's less than or equal to negative 14, or x is greater than 8. And then it's a bracket on the negative 14 to the left, and a bracket on the 8 to the right. So negative infinity to negative 14, and 8 to positive infinity. You're welcome. And then remember the special cases here. Like if it says absolute value is greater than a negative number, it's all real numbers, because every number outside of absolute value is going to be greater than a negative number. And vice versa, absolute value is less than 0 or less than a negative number, and it's no solution, because no absolute value can be less than 0. Yeah.
Why are there parentheses besides the infinities?
So if it's not or equal to, like notice the difference between these and this, that's or equal to on the right. The or equal to gets the bracket because it includes that number. And the not or equal to, so on the left, the yellow ones, those don't include the numbers, so they get parentheses. Because technically I'm saying it has to be less than 8, right? Which could be 7.9999999, but I can't write that. So I just put the 8, but say, put a parentheses on the 8, which means I go up to the 8, but I can't include the 8.
Yeah. So, but like, why is there parentheses besides the infinity sign?
Oh, like on the infinity?
Yeah, like besides it.
You,
So, like, why aren't there brackets on both sides?
because infinity is not a number. So you can never include it. So negative infinity and positive infinity will always get a parentheses.
Okay.
Is that what you mean?
Yes.
Yeah, okay, yeah.
When you subtract the -2 from the -10,
Yeah.
it would be -18.
No, it would not. It would be -12. Good job. Yep. 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 The process is important, right? Yeah, okay. That part was right. The math is, the arithmetic, not important. All right, then came what we finished on Friday, which was the fractional inequalities. So for these, I have to get everything to one side. I have to get it to one fraction. So I would subtract that 2. I'd get x plus 1 over x minus 3 minus 2 is less than or equal to 0. I need to give it a like denominator. So I would multiply by x minus 3 and x minus 3. I'd get x plus 1, distribute this, minus 2x plus 6 all over x minus 3. And I get negative x plus 7 over x minus 3. This time when we change it so it has the least common denominator, we're not multiplying everything out by it. So I can't cancel the denominators when it's an inequality. When it's the equals we do, when it's the inequality you can't. And now I split and solve. So I split both my numerator and my denominator. I get x equals 7 and x equals 3. 3 and 7 go on my number line. I plug in a value, zeros to the left this time. And you can plug it in at the beginning or once you got it to the 0. From the beginning, it would be 0 plus 1 over 0 minus 3 is less than or equal to 2. Negative 1/3 is less than or equal to 2. So the outsides get shaded. Now what's the catch with the brackets and the parentheses on the fractions? Good. You can never put a bracket on what comes from the denominator because it would make my whole fraction undefined. So that 3, which is what came from the denominator, gets the parentheses and the top gets the bracket because this original sign is or equal to. So negative infinity, oops, that's an 8. Negative infinity to 3, bracket 7 to positive infinity. Maybe you have 2 fractions in the denominator or like something there. So you could have 2 that come from the denominator, 1 that comes from the top. But it's still every other as long as it's not repeated and we didn't put a repeated one. Yeah. Yeah. I Yeah, so when you raise it to the 3 halves, you're square rooting it. So it's plus and minus the square root of 49 to the 3rd, which is plus and minus 7 to the 3rd, which means there's 2 answers. A negative 7 to the 3rd and a positive 7 to the 3rd. So that's negative 289. The numbers are not this big, but, and 289.
289.
No, 343. Sorry, just kidding. Hey, look, I just made a mistake for you. 343.
So they're gonna be like that?
Like not that big, but there's gonna be a question like that, yeah.
Can you put that exact question on the
Nope.
right? It's right.
I mean, I can, but I didn't.
Wait, which one's that?
The first one.
Mr. Cesar, if he forgets to write like the U, are we gonna get?
I don't think so. I didn't ask, but I don't think. As long as you have it separated in some way, like there are 2 separate ones.
You don't check, well, you still get partial.
You'll get partial, maybe 1 or 2 points, like, because these actually both work this time. You would plug it back in. Like I would say negative to the 2/3, which means, minus 1. The cube root of 343 squared. And that's, actually, they don't both work this time. No, this one doesn't work. So you'd get 7. If it's positive, you get 7 squared, which is 49. So that one works.
We're placing.
But then the negative,
With A. So this square.
oh, no, it is positive 40. It's still positive. That's still 49. So they both work this time.
And then now you just use basic math. And then
I think that's a
All right, so this is the one where we substitute, right? What is A?
1/3 x minus 1.
X minus 1 to the 1/3. Good. What? I just did it. Hmm.
was it okay, hold on.
All right, so this one gets factored, right? A minus 6, A plus 1, split and solve. A equals 6, A equals negative 1. And then we set it back equal to what A equals. All right, and then X minus 1 to the 1/3 equals negative 1. Shh, guys. Shh. Yeah. Yeah. All right, then I'm going to cube both sides. This is 216, right? And then add the 1. Is it? 36 times 6. Yeah, 216. 217, and then cube this. X minus 1 equals negative 1, and then add the 1.
I got the answer right.
This one should be easy, right? What would I have to do here?
Cancel out those.
Just cube both sides, and I get 2x minus 7 equals 7x plus 9, and then solve the equation. So don't let ones like that throw you off. That's easy stuff. As a matter of fact, if you're like struggling on something else, skip and find questions like these, get the easy ones right, and then go back to the torturous ones. So x equals negative 16 over 5. And it's a cube root, so we don't have to worry about checking. If it was an even root, that's when I would go back and check.
How would